today what we're looking at is still factoring polynomials, so doing the same thing, um, but they are going to be more complicated polynomials. And by more complicated, all I mean is the a value. Um, a value will not equal the number 1. So process. Now, this is very similar to this RS method for factoring we talked about yesterday. Okay, so we're factoring trinomials. Remember, trinomials, I've got it written right below me there. Trinomials, in general, they're going to be quadratic trinomials. Um, Quadratic just means its highest degree is x squared. Okay, but today they get this added condition that a does not equal 1. So a up here is going to be 2, 3, 4, 5, 6, negative 2, negative 3, negative 4. But it's not going to just be x squared out front. There'll be some number in front of it. So let's take a look at how we attack this. If you remember yesterday, what we had to do is we wrote down the values c, and then we looked for those two numbers, r and s, that met two conditions. Today we really just have to add two more steps to this little algorithm we have, this little process to factor our polynomials. So let's look at the first thing we're going to do. Okay, the first thing you have to do is you're going to multiply the a value by the c value. So again, if you remember how our standard form looks, you're going to take a and you're going to multiply it by c. And that's going to give you a new number. Okay, and that new number is just whatever the product of a times c is. And instead of just looking at c, like we did yesterday, to find the r and the s, we look at this new value, this a times c value. And that a times c value has to meet the same conditions we had yesterday. The product of r times s has to equal the a times c, not just c anymore, but that product we found. And at the same time, those two numbers that we come up with have to add to b again. So it's just like yesterday with this one extra little step, where instead of just saying, hey, we've got to find a product that gives us c, now we have to find a product that gives us ac. And so you're going to go through that process, and then you're going to be able to write the factors. But look at the way we write the factors now. Instead of just x plus r, x plus s, we write ax plus r and ax plus s. And our a value, of course, is that number out front. Once you do that, what you're going to find is that both of these factors have a GCF in them. And so you got to suck that GCF out of each of these. Okay, this is step 4 there. Take the GCF out of both factors, and you just cross those out and throw them away, and you'll be done. Okay, so let's look at this in practice. So here we've got a polynomial. I would check it for a GCF. Okay, so we look at our coefficients here. 3, 10, and 7. 7's not really a coefficient, it's called the constant. And they are not all divisible by the same thing. 3 is only divisible by 1 and 3, and neither 10 and 7 are divisible by 3. So let's take a look at our variables. And x squared, x, no x's on the last one, so we can't take any variables out. So this already has been GCF'd. So let's do step 1 here. Step 1, we're going to take A times C. And in this case, that would be A is 3 times C, which is 7. 21. Step 2. Now we're going to meet those two conditions. So we write down the 21, we write down R and S, and we start to make our list. Now this time, remember again, we're still going for this B value, so we want two numbers that add to negative 10. So let's start writing them down and see what we find out. It could be 1 times 21. It could be 3 times 7. That's looking pretty good. Could be, that's it. Let's check what they add up to. This one adds up to 22. And this one adds up to 10. Oh gosh, we wanted a negative 10. And in this case, what we can do is make both these negative, okay? Because negative 3 times negative 7 is also equal to 21, and I shouldn't be using my eraser to point stuff out, is also equal to 21. So if we use negative 3 times negative 7, I get the 21, and now instead of adding up to 10, they add up to the negative 10, which is what I wanted in the middle, right up there. Okay, we're ready to write down our factors now. Okay, now to write down our factors, again, it's going to be AX plus R times AX plus S. So for this problem, A is our 3 up here. The very top, that's our A. 3x plus R is negative 3. And then 3x plus S, and S is negative 7. Now all we have to do is look at both of these, see if there's any GCF we can take out. Okay, and we look at them individually, so let's see what he has. Okay, each term is divisible by 3, so let's pull that 3 out. Oops. Giving us x minus 1. The other term, 3 and 7, they do not have a GCF, so we just leave it like that. And then whatever you pull out, you just cross that guy out, and this is your final answer. I'm going to run up here and I'm going to check him real quick so you guys can see he does work out. And here we go. Distribute x, 3x squared. Distribute x, negative 7x. Distribute negative 1, negative 3x. Distribute negative 1, positive 7. 3x squared minus 10x plus 7. Yep, he checks with the original problem. So yeah, this is our answer. So it seems like a little bit more complicated process. It's not. There's really 2 extra steps. Step 1, you got to do this AC, and then you got to work with that number to find your R and S. And then after you write your factors down here, you got to do this GCF step. All right, so let's take a look at Okay, let's check for a GCF. I do not see one. 5, only divisible by 5, and 52 is not divisible by 5. You have to end in 0 or 5 to be divisible by 5. This one ends in a 2, so that doesn't divide by 5. And x squared, x, no x's, so x squared, there is no common factor. So find AC. 5 times 20. That's 100. Oh my, that's kind of big. That's all right. I think we're going to be able to solve this one relatively easily. So now we write 100 down. That's what we're going for with our R times S product. Okay, and again, you could go 1 times 100, but that doesn't get you close to 52 when you add them. 2 times 50, that's looking pretty good, because 2 times 50 is 52, or is 100 rather, but it adds up to 52. Now again, we are going for a negative 52, so we're going to make both of these negative. Negative 2 times negative 50 is still 100, positive, and when you add them now, you get a negative 52, and that's perfect. It's exactly what we want. And so we just come over here, we write again to remind you ax plus r times ax plus s. So ours will be a is 5, x, or y, keep switching, will be 5x minus 2 and 5x minus 50. Let's check this first one for a GCF. 5 and 2 are not both divisible by the same thing. Let's check 5 and 50 here. Yeah, they're both divisible by 5. So we'll pull that, factor that 5 out, giving us x minus 10. Then simply cross out that GCF. 5x minus 2 times x minus 10. And assuming we did everything correct, that should be just perfect. So I'll run over here and I'll check him real quick. It'll be 5x squared when I distribute and negative 50x when I distribute. It'll be negative 2x when I distribute the 2 plus 20. 5x squared minus 52x plus 20. Boom, boom, it checks. We have our correct answer. Here's what your homework looks like. Okay, it's just 6 problems using the process we just looked at. Now I'm going to run back to the first page